Okay, shall we start our session?
Okay, sir.
Okay. First of all, let me confirm whether my slide is available. Can you able to see my slide now?
Yes, sir. Yes.
So what is in my slide? Hello? What is in my slide?
Type of distributed systems and grid computing.
Types of distributed system and grid computing. Okay, great. Okay, so in the last lecture we looked at a large scale system we have already discussed, and in the last lecture we discussed some of the aspect comes under this distributed system. So any idea about this distributed system? What is distributed system? Okay, basically a distributed system is a connected component, the network that are working together to accomplish a task. Maybe it can be in geographically dispersed. So these distributed system components work together to accomplish a task. Basically, it's a system, a collection of autonomous computers cooperating to complete a task. So we looked at various aspects under this distributed system. But today also we are going to discuss, after that we looked at some of the how these distributed systems are working and the goals of a distributed system and the example of distributed system. They are under this example of distributed system. We looked at various types of various distributed systems examples like local area network, database management systems, and automatic telemachines network, internet, world wide web, and web servers and web browsers, and mobile and ubiquitous computing. And with that example, we looked at some more example also for these distributed systems. Today we are going to discuss the type of distributed system and the grid computing. The type of distributed system and grid computing. First, under this today's session, we are going to cover up the following areas. First, we will discuss the types of a distributed system. Then we will move into this grid computing. After that, we will discuss what are the applications of this grid computing and methods of grid computing. These are the areas today we are going to discuss in this today's session. Okay. So, you know, this distributed system, distributed computing, these are geographically dispersed, and these components for these distributed computers are connected through a network, and they are sharing the data or storage or the bandwidth or its computing power to accomplish or to carry out a specific task. So based on this, we may say its size or the functionality. We may categorize this distributed system into various types. The type one of distributed system, we can call it a distributed computing systems. Basically, we call it a distributed computing system. So basically, these distributed computing systems are used for high performance computing tasks. So high performance computing, you might heard about the term high performance computing. It requires large volume of data processing, and it requires high computing power for a special kind of task. So a little later, I'm going to introduce each type of distributed system in detail. So basically, this type 1 distributed computing systems are used for high performance computing tasks like forecasting or doing huge amount of calculations or computing. So they are using high performance computing, or if they require any kind of a supercomputing power, they can comes under this type 1 distributed computing system. And there the cluster and cloud computing systems are also comes under this distributed computing system. So you might heard about this cluster computing. What is cluster computing? Any idea? Any idea cluster computing? Any idea? Any idea about this cluster computing? Okay, so basically, the idea behind this cluster computing is these are the collection of computers that work together. This collection of computers have worked together, and this collection of computers can be viewed as a single system. Viewed as a single system. So this is also this kind of system also can be treated as a distributed computing systems. A little later, I have an example to discuss the type 1. That time you can understand. Okay, cloud computing systems. Any idea about this cloud computing? Cloud computing systems. Am I audible? Cloud computing systems. Any idea?
Virtually access the data, sir.
Okay, great.
Keeps our data on the cloud storage.
Okay. Cloud-based cloud computing systems. Okay, great. Cloud computing systems mean instead of the physical, what do you call this, hardware, software, and the infrastructure, the computing services and applications and infrastructure can be from in a cloud-based, not a physical, in a cloud-based. So the users can access its service, different kind of service they can access, like they can get the service like infrastructure as a service. There are various classifications comes under this cloud computing. So the users, I mean the companies can get the cloud service as a software as a service. They can, we call it a SaaS, software as a service, and they can get the platform for their data processing and storage. They can get the platform as a service, and even they can get infrastructure as a service, IT infrastructure as a service from the cloud environment. So rather than spending huge amount of money for this IT infrastructure and IT services, they can hire these cloud-based IT solutions or IT services from the third-party organization or a third service providers. So cloud-based cloud computing systems. And a grid computing system. Any idea about these grid computing systems? Grid computing systems. Grid computing. Any idea? Grid computing. Any idea?
It's a collection of computer resources from multiple locations to reach a common goal.
Okay, great. Any other idea? Hello? Any other idea? Okay. Grid computing mean it's a set of collection of unutilized computing power, computing cycles, or storage capacity to accomplish a task or to finish a to utilize that computing power, grid computing. A later part of this session, we are going to discuss the grid computing in detail. Okay, the second type. What is the second type of distributed systems? Hello?
Distributed information system.
Sorry?
Information system.
Sorry?
Distributed information.
System.
Okay, great. So the first type we looked at distributed computing system. The second type is distributed information system. So we have already discussed various kind of enterprise level system. What are the different enterprise level system we looked at?
Supply chain management system.
Sorry?
Supply chain management.
Supply chain, ERP,
Knowledge management system.
knowledge management,
Customer relation.
customer relation. Yeah, great. So these are different type of enterprise level systems, and basically this type of distributed system, type 2 distributed information systems are basically for industrial, so enterprise wide information system, large scale enterprise wide information system. So basically this kind of information system, distributed information systems are for a system mainly for management and integration of business functions. Management and integration of business function. So it is a hidden term for ERP systems. So mainly for management and integration of business functions. So what are the business functions? The routine business functions for a business enterprise. Let's say their routine operations are like manufacturing and what are the others? Marketings, accounting and finance, HR related activities, sales. So these are some routine business functions. So to integrate and manage these kind of functional areas activities, we need what? Hello? To coordinate or to manage or to integrate all these functional areas activities, we are installing or we are establishing a ERP system inside the organizations. So companies are using enterprise system, ERP system, enterprise resource planning systems. Yeah. So likewise, the transaction processing system. So large scale, you might heard about this transaction processing systems are in the organizational hierarchy from the operational levels, from the bottom line. From the bottom line, there are systems called transaction processing system. Those systems are in a daily basis. These systems are providing or these systems are handling the data and informations to provide some process data to the next level, like managerial level or a strategic level, the transaction processing system. So enterprise application integrations, what does it mean? Enterprise application integrations. Any idea? Enterprise application integrations. Any idea? Enterprise application integrations. Any idea? Okay. Do you remember when we are discussing this enterprise resource planning, so ERP system, we looked at ERP systems are in a modular base. Modular base. Modular base mean what? Module base. So these ERP systems are designed for each functional area requirement. I mean, for each functional area, we can install the particular module. Let's say for sales and marketing, one module. To handle this sales and marketing related activities, one module is there. To handle this finance and account related activities, the separate module is there. To handle this HR related activities, separate module is there. And to handle this, what do you call, manufacturing and production related activities, there is a separate module. For the research and development, another separate module. So actually, the ERP system is a collection of modules which serve for each functional areas or a business unit. Do you agree? Hello? Hello? Can you
Yes,
hear me?
sir.
Hello?
Yes, sir.
Okay. In this case, so based on the business organization's requirement, like let's say if they need only the basic functional areas like let's say accounting and finance, sales and marketing, and the manufacturing and productions, and what do you call this, HR related activities, the four basic functional areas. So they can implement this four, install and maintain the four basic modules. Assume that now they are going to expand their business operation and they are going to sell their product and services in online platforms or website or e-commerce site. So this time they are going to integrate. So they are going to integrate that particular e-commerce module into their existing systems. So kind of integration. So we call it enterprise application integrations. So in some other cases, the existing organization system has to integrate with other stakeholder system like supply system, suppliers. So we are dealing with suppliers. We are dealing with this outside service providers. So outsiders system like supply systems, outside vendor system, outside service provider systems. So kind of integration, enterprise level integrations. So sometime with the existing ERP system, we have to integrate our other enterprise level system like let's say customer relationship management system, knowledge management systems, those kind of integrations. So we call it enterprise applications integrations. But the idea. Hello?
Yes, sir.
Yes, sir.
Hello?
Yes,
Yes,
sir.
sir.
Oh, okay. Then what is the third type? Type 3? What is the type 3? Hello? Type 3?
Distributors, ubiquitous system.
Type 3? Can't you find any type 3 system here?
Distributed, pervasive, or ubiquitous system.
Great. So type 3, distributed, pervasive, or ubiquitous systems. So we looked at in the last lecture also mobile and embedded systems like the smartphone and some of the IoT devices, sensor devices, these kind of systems, and home systems. So these days you may observe due to these advanced technologies, the smart home, they have various kind of IoT devices and sensor devices, and then these embedded devices. These are communicating through this network, and this can easily control, and the devices can home appliances and home devices can easily functions in the smart home network. Sensor network, third category of under third category, sensor network. Any idea? Sensor network? Basically, sensor network is a collection of devices, and these devices are connected through wireless or wired infrastructure, and they are working to transfer the data and information. So in the smart factories or hospitals, in healthcare sector, they're having this as a sensor network to transfer the data. Okay, so these are the three major category of this distributed system. So the type 1 and type 2 and type 3. So when you look at these three types, can you able to summarize its focus or its area, the type of distributed system is going to serve? You see, the type 1 distributed systems are for entirely for some special task or special requirement. So the high performance computing. So basically it's for some basic special requirement, like to perform huge amount of calculations or computations or forecasting or some kind of predictions, some kind of analysis, modeling. So these are a special kind of requirement. So This is actually for the type 1 is actually for the computer system. These are for some special procurement or a special kind of task. How about this type 2? How about this type 2? The type 2 distributed systems are for industrial applications. Here you see, basically they are implementing this distributed information system in the industry level or enterprise level to integrate their functional areas or to integrate some kind of enterprise level systems, as I mentioned earlier, ERP systems or some other modules. So they need this distributed information system in the industry, enterprise level. Then how about this, the type 3? Hello? Hello? Actually, the type 3 is for smart devices, embedded devices, and the sensor network. Basically, smart devices and handheld devices and embedded devices. We call it distributed pervasive systems. So now for the industrial and the special task and the smart computing, smart device requirement, based on this three kind of requirement, we can classify the entire distributed systems into three major types. What are those? Hello? Can you all hear me? Am I audible?
Yes, sir.
Okay. We looked at three major type of distributed system. Now we are going to discuss in detail about these three systems, distributed system. The type 1 cluster computing systems. Here you see we looked at cluster computing, also one type of distributed system under type 1. So type 1 cluster computing, collection of similar pieces, so closely connected pieces or not, all are run on the same operating system. So here you see a collection of devices are connected. So master node, a compute node, and compute node. So there are several compute nodes are there, and all the computers or compute nodes are connected with a master node. And there are connectivity like standard network, high-speed network, and remote access network. So here you see the collection of computing nodes plus master node, and master node can run middleware, parallel execution, and management. So there are several middleware between this master node and the compute node. So all these compute node can do some kind of function like computation, so calculation, so kind of analysis, so modelings or forecasting or computational tasks. And the master node can get the power of these compute nodes, and it can serve or facilitate the computing services to the other connected components. So cluster. So basically, master node receive client request, handle the job, and the allocation of nodes to a particular parallel program. So various kind of industrial requirement like high performance computing tasks and the cluster and cloud computing tasks. They may want to calculate or compute or analyze huge amount of data. So that time they can apply this cluster computing system. So basically it is for the industrial requirement. I mean, special kind of procurement, they can have these cluster computing systems. Grid computing. So grid is basically for autonomous unutilized computing resources. It can be computing power or server or storage capacity or bandwidth or networking capacity can be utilized for some special requirement. So grid computing. A little later, we are going to discuss this grid computing in detail. Here you see the computing as a utility. So distributed computing as a utility here in the cloud-based environment. So here you see from the internet, there are companies and a client or the users. So in the internet, there are cloud-based services like software as a service. They may provide some application software like let's say accounting packages and ERP systems or some other word processing packages or any kind of software as a service through this network to their users or a client. And platform as a service. Platform as a service means they can provide computing platform as a service to the users. So computing platforms, storage capacities, so kind of platform. And the infrastructure as a service, So IT infrastructure, storage capacities, databases, some kind of processings. So these are infrastructure as a service. So here you see for the users who are connected end users and the client, with the help of internet, these services can be provided. So the users has to pay the subscription fee for these service providers, and they can enjoy or they can use these services. It can be a software as a service, platform as a service, or infrastructure as a service. So the cloud computing is providing these services to their connected users or a client. Good idea. So basically we call it computing as a utility. All are the computing services, computing as a utility services, like our electricity and water and telephone. So these are some kind of home utilities. Likewise, here the services, software as a service, platform as a service, infrastructure as a service, all these computing services are referred as a services, computing utilities, computing as a utilities to their connected users or a client. So instead of investing huge amount of money for softwares and the platform and IT infrastructure, the business organization can easily get this service from the service providers by paying the subscription fee or the service charge. They can easily hire these services from these organizations. 4:35 hours. Okay. What the idea about this cloud computing?
Yes, sir.
Yes, sir.
Okay, great. So now we are going to move into this second type of the second type of distributed system. Type 2 is distributed information system. Basically, these distributed information systems are serving for enterprise level application or enterprise systems, enterprise application integrations. Here you see allowing existing application to directly exchange information using communication middlewares. In this case, here you see communication middleware is there. The client applications are there and server side applications are there, and they can connect or they can integrate these client and server side applications through this communication middleware. So then they can easily share their data information. So they can easily process the client request. So the server side is responding. So middleware as a communication facilitator in enterprise application integration, so then they can easily share the data and informations in this enterprise application integrations. Okay, the third one. Third one is what? Third type? Distributed? Pervasive systems. Okay. Look at this third category of this system, distributed pervasive system. Basically for smart devices and embedded devices, these pervasive systems are designed exploiting the increasing integration of services and computing devices in our daily physical world. So mobile devices, smart devices, discover the environment, its services, and establish themselves in this environment as best as possible. Like these days, most of the people are using smartphones to interact with other connected devices and sensor devices in IoT devices. Procurement for pervasive applications embrace contextual changes. And here look at this smart home systems. There you see in our smart home, in this smart home, there are devices inside this smart home. There are devices. It can be a smartphones or sensor devices or IoT devices or any other embedded devices like you see. So these home appliances and home applications or devices can be easily controlled. So its functions can be regulated. So there are, you see, there are smart TV and some sensor or embedded devices. And you see kitchen appliances. You see there are refrigerator, washing machines, and some other kitchen appliances, electrical appliances. And you see there are various kind of devices, sensor and IoT devices. These can easily communicate, and the smart home can be controlled, monitored, and its function can be regulated. So then they can easily control the devices inside this smart home, like let's say the door closing, like it is a sensor device. It can authenticate or recognize the actual owner of this home. And when the person is placing his fingerprint or by recognizing his identity like iris or some other unique identity, the door can automatically open. Once the person entered into the home, door automatically closes and the light is automatically switch on. And when the person move into another room, the light is automatically switch off. And when he entered his entertainment place, the television is automatically playing some movies, So these are some controllable or some kind of smart systems which can easily function, so which can be easily controllable by the users or owners. And even with the help of voice, these devices, these embedded devices easily can recognize the owner's voice, and with a command or instruction from the owner or a user, these devices can function. Like when the user or the owner command like increase the volume, the device automatically increase the volume. When the user say the instruction like shut down, the device automatically shut down its functions. So these are the smart home systems. These days in developing countries, they are designing the smart home and they are designing more facilitated and sophisticated home for their users and owners. you might heard about the term these smart cities, and in the smart cities, there are various kind of IoT devices like smart parking, smart light, smart traffic systems, smart vehicles, smart food delivery systems. Various kind of sophisticated and advanced technologies are used in the smart cities. Okay, good idea.
Yes, sir.
Okay, great. So here you see, here are some smart home systems or devices like integrate personal devices like mobile phones, smartphones, and wearables, IoTs. Wearable mean the wearable devices like, let's say, smart watches, wearable smart watches. So these watches can easily sensor your temperature, your pulse rate, heartbeat, and it can easily count your blood pressure. Everything it can easily count. The smart wearable shoes, it can easily count your footsteps, or running, or walking, or your exercise pattern, everything. Wearables, smart shoes. Integrate home apparatus like light, alarms, entertainment systems, and thermostat control sense the temperature inside the home. There are devices to control that. There are devices to detect or sensor the temperature. So based on the temperature, it can regulate some other connected devices also. Configuring and self-managing devices. So automatically it can turn on, automatically it can configure based on the conditions, or based on the command. It can automatically configure, automatically manage, automatically regulate devices. Take care of your information like music, photos, videos, calendars, health informations. So these smart home devices and systems are take care of your information like your preference, your preferred music. When you are when you are in the entertainment place, so it will automatically play your preferred music or photos, preferred images or photos, galleries, videos, films, your calendar schedules. It will remind your times and schedules, events, calendar schedules. It will automatically remind you. Today, 10 o'clock, you have a meeting. 12 o'clock, your friend is invited for the lunch party. You have a wedding ceremony in the evening. So all the informations will be updated for your notice. Health information, for your health informations, like your pressure, heartbeat, your body temperature, your what do you call this? Body temperature, everything can be, your health information can be updated. So it protects your personal space from others. So it can easily, it is very much conducive and very much supportive for you. So then others are away from you. So you don't need to depend on others. So the systems are helping you to live in a smart way. So if possible, look at this Google Home. There are videos in YouTube. You can look at this Google Home, and there are smart home. There are designed smart home. When you look at these videos, you can get more idea about these smart home systems. So one example is Google Home. Look at it, how they have integrated the systems, or how they have integrated or fixed these devices and system in the smart home. What's the idea?
Yes, sir.
Okay, great. Okay, with that, we will move into this the next part of today's session. That is grid computing. Any idea about this grid computing? Okay. So basically, it's a kind of distributed system. Basically, grid computing is a kind of distributed system that are facilitating to share selections and aggregation of geographically distributed autonomous resources. So geographically distributed autonomous resources are aggregated and shared in this grid computing. Grid computing is a form of distributed computing, thereby a super and virtual computer is composed of a cluster of networked, loosely coupled computers acting in concert to perform a very large task. So basically, this grid computing is a collection of computers. These are the cluster-based or loosely coupled computers, and these are performing for a large computing task, large task. Grid computing is a growing technology that facilitates the execution of large-scale resource-incentive applications on geographically distributed computing resources, like the branch office may be in one location, headquarters may be in another location, regional office can be in another locations, and there are resources, computing resources like servers are in one place, and databases are in one place, applications are in one place, and they may have a knowledge management system in another place. So these computing resources can be geographically distributed, and it can work together to accomplish or to finish a very large task. Grid is a utility or infrastructure for complex, huge computations where remote resources are accessible through internet from desktop, laptop, and mobile phones. So in this grid computing, for a large, it's a kind of utility, it's a kind of computing service or infrastructure for complex, huge computation. These grid computing services can be accessible through this desktop, laptop, and mobile devices. By using these devices remotely, you can access with the help of internet. Remotely, you can access these services. So in the second note, the previous notice we have already discussed the same kind of meaning. The second note, the nodes can include servers or personal computers that are loosely linked together by the internet or other network, and in many cases distributed across multiple geographical regions. So it can be from various physical locations, but these can work together with the help of the network to accomplish a huge procurement or a task. Grid computing provides an architecture for creating a virtual supercomputer made up of distributed computing nodes. So there are possibilities to get a virtual supercomputer. You know, the supercomputing power is very high. So compared to other computers like mini computers or other kind of computers, the supercomputers have a huge amount of computing facility and huge amount of computing capacity. So it can compute and it can handle huge amount of data. So with the help of this grid computing, its architecture can create virtual supercomputers with the help of by combining or by integrating various distributed computing nodes. Got the idea? Hello?
Yes, sir.
Basically, the idea behind this grid computing is from distributed computing. Now look at this diagram. Here you see the world map. Assume that in the world there are various part of the world is in this picture. See the locations here in this one. I mean, yeah, let me show you with the annotations. Look at this locations. This geographical location is in America. Look at here. This is from let's say yeah, it's from South America. So Mexico, some, yeah. This is also American country, Mexico or some other countries. And here you see these are from, yeah, African continent. These are from which one? Which part of this world? This one?
Europe.
Europe, exactly, Europe. How about this one? This area? Asia. Huh? Am I correct?
Yes, sir.
Yes, sir.
How about this one?
Australia.
Australia.
Australia, exactly. You see, so various part of the world and the distributed components. So what are the components? You see from here, see the notation of these components. See the notation of this component. You see, supercomputers. What else? What is this?
Satellite.
Satellite. This one?
Storage.
Storage, databases. This one? Clusters. Clusters mean collection of computer nodes. Clusters. This one?
Virtual
Virtual
organization.
organizations.
Organization. This one?
User.
Users or researchers or scientists. So these are the people. These people are going to access these computing systems. You see, in each part of the world or continent, they have a distributed component. In each component, they have several or collection of computing resources like storage capacity, clusters, and supercomputers. So the collection of components are in each geographical locations. In this grid computing, assume that the idle part or unutilized components can be connected together, and it can serve or it can support to perform some special or a special computing task, some kind of analysis or some kind of what you call computations or some kind of predictions, forecasting, or simulations, any kind of task. So this is how this grid computing is working. So this is one example. If it is organized in a context like this geographical part, we may say branch offices or regional offices. And for the headquarters, all the branch office and all the regional office computing components are helping or supporting to compute huge amount of calculations or to get a huge amount of computing power or to do a analysis, to perform computing task. So this is how this grid computing is working. Good idea. Hello?
Yes, sir.
Yes, sir.
What the idea?
Yes, sir.
Yes, sir.
So you see, nowadays, the computing requirement is very high. So the industries and from the scientific organizations, in the government, and some other institutions, the computing requirement is very much high. So you see, today's science is based on computations, data analysis, data visualizations, and collaborations, like scientific activities like NASA. Think about NASA and some other research institutions, or some other science research institutions, some experimental institutions. Their computing requirement is very much high, and those people are those institutions are analyzing huge amount of data, big data, data analysis, and data visualizations, data simulations, various computing requirement. And computer simulation and modeling is more cost effective than experimental models. Computer simulations and modeling is more cost effective than experimental method. In a sense, if they want to practically do the experiment, or if they want to practically do the calculations or get its functionality, it will take time, as well as sometime it will cost also. So what they can do is, they can, by using these advanced technologies, they can do the simulations and they can do this modeling, so then they can get the idea behind this actual experiment. So rather than doing this experimental, the physical experiment or a practical experiment, so they can perform the simulations or a modeling. So different kind of computing requirement. And scientific and engineering problems are becoming more complex. Users need more accurate, precise solutions to their problem in short possible time. So the scientific and engineering problems are becoming more complex. So day by day, it is getting more complex. And they require, the scientists and engineers, they require more accurate, precise solutions to their problem in shortest possible time. So within a short period of time, they need the solutions for their calculation, computation, or some kind of engineering task, scientific task. So their computing requirement is entirely different, and they need a special kind of requirement. They have a special kind of requirement, you see. So likewise, in the industry also, there are several requirement, like industry, business organization has to handle various kind of huge amount of data. There are different type of data, structured data, unstructured data, and they have to deal all this kind of data. They have to collect the data from various sources. Yesterday we looked at, for you, your junior page, various kind of data they have to collect it, and various sources, various online repositories and databases are there to collect the data, to process the data, to find the solution for their decision making. So various requirements from the industry side also. So they have this great applications for this requirement. So data and computational incentive applications, like this technology has been applied to computationally intensive scientific, mathematical, and academic problem, like drug discovery, economic forecasting, earthquake analysis, back office data processing in support of e-commerce. So these are some kind of requirement. So this grid computing is applied in these areas, like highly computational incentives scientific activities, like let's say the NASA, or some other scientific application, scientific research. So they are applying this grid computing, mathematicals, modeling, so mathematical related calculations, computations, simulations. They are using engineering related tasks, academic problems for research and research activities, and in the medical field for the drug discovery, to find the drugs, so medicines. So in the business side, economic forecasting, economic forecasting, the countries for the industries, economic forecasting, earthquake analysis, some natural disasters like earthquake, forecasting its analysis. And if it is an industry or an enterprise level, there are applications like e-commerce site, e-commerce applications. So huge amount of customer data can be processed, huge amount of transaction, business transaction can be handled, various kind of application, grid computing applications. Chemists may utilize hundreds of processors to screen thousands of compound per hour. In a sense, chemist hundreds of processors can be used to screen, like a filter or separate or extract thousands of mixture of chemicals. So chemists, they have a various kind of requirement. Teams of engineers worldwide pool resources to analyze terabytes of structural data. So engineers are dealing with this data. So thousands of data sources can be integrated. Like you might heard about gigabyte, megabyte, gigabyte, terabyte. So these kind of thousands of millions of bytes of data can be easily analyzed for this engineering related task and activities. Meteorologists seek to visualize and analyze petabytes of climate data with enormous computational demands, like meteorologists, the people, those who are deal with this weather forecasting. So they can visualize and analyze petabyte, megabyte, gigabyte, terabyte, and petabyte. And there are various kind of categories, petabytes, climate data with enormous computational demands. So these are some kind of grid computing applications. And resource sharing, like computers, resources, sensors, and network. These are the resources can be shared in this grid computing. Coordinated problem solving, distributed data analysis, computation, and collaboration. So in this distributed computing, in this collaborated grid computing, so the idle or unutilized computers can link together or work together to perform these special kind of computational tasks. So distributed data analysis and computation, this the problem solved or saves are provided by this grid computing applications. Distributed data analysis, some kind of special computation, huge amount of computation and collaboration. They can these resources, idle resources or autonomous resources can be collaborate together and they can accomplish a task. What the idea? Hello?
Yes, sir.
What the idea?
Yes, sir.
Okay, great. And here you see there are in this grid computing, there are terms in the computational grid and data grid. Basically, the computational grid is refers. It's a hardware and software infrastructure that provide dependable, consistent, pervasive, and inexpensive access to high-end computational capabilities. So here you see computational grid. This kind of a grid computers basically covers the computation part, high performance, computing power, computational operations. So computer grid is a hardware and software infrastructure that provide dependable, consistent, and pervasive, inexpensive access to high-end computational capabilities. So it can perform high performance computing. Say for example, US Department of Energy. So they can perform. They may have this high performance computing grid. The data grid. Whereas the data grid is a grid computing system that deal with data, the control, sharing, management of large amount of distributed data. So basically it refers the data grid, the storage capacity, data is a grid computing system that deal with data, the control, sharing and management of large amount of distributed data grid. The data grid is the storage component of a grid environment. Scientific and engineering applications require access to large amount of data, and often this data is widely distributed. So for the science and engineering related applications, they need this large amount of data, and this data can be from widely distributed. So they are locating or they are storing this data from various distributed environment, so then they can manage or they can easily get this data for their computations. Data grid provide seamless access to the local and remote data required to complete compute intensive calculations. So for example, Biomedical Informatics Research Network and the Southern California Earthquake Center. So these are some research institution or institution, they are dealing with this data grid. So we looked at the computational grid. Basically it focus the computing part. The computational power, high performance computing and the data grid. Basically this kind of grid computing focuses the large storage capacities. The grid is the storage component, and this kind of a data grid computing is providing or handling large amount of data and it provides services for science and scientific and engineering related applications. What's the idea? Hello? Hello?
Yes, sir.
Shall we move to next slide?
Okay, sir.
Okay. So next we are going to discuss about methods of grid computing. So now you know what is grid computing, and its different type and a different type of computing and its services. Its applications, grid computing requirements, applications. Now we are going to discuss about methods of grid computing. So these are some of the architecture or methods comes under this grid computing. What are those? What are those? Under this grid computing, there are different type of method or architecture for this grid computing. So what are those?
Distributed supercomputing,
Distributed supercomputing,
Okay.
high throughput
high
computing,
throughput computing,
Okay.
on-demand computing,
Okay.
data intensive computing,
Okay.
collaborative computing,
Okay.
Logistical
What is the last?
networking.
Logistical networking. Okay. So the previous slide, we looked at various grid applications, you see, and the computing requirement also. Based on the computing requirement and its grid applications, the grid computing architecture or its method can be in this form, like a distributed supercomputing, high throughput computing, on-demand computing, data intensive computing, collaborative computing, logistical networking. Now we are going to discuss about each kind of method or architecture in detail. So distributing supercomputing. So the term itself has the meaning supercomputing. So they require super power to compute, supercomputing power. So this kind of applications or this kind of requirement, like the ordinary or a normal level of computing power is not enough for them. So they require supercomputing power, high performance computing power. So combining multiple high capacity resources on the computational grid into a single virtual distributed supercomputer. So thousands of nodes, thousands of nodes are collaborated or connected, and these are providing high super computing power for this application. So distributed supercomputing tackle problems that cannot be solved on a single system. So these supercomputing grids are handling huge amount of these are handling a complex problem that cannot be solved by a single system. So it means the single system computing power is not enough to solve this problem. Single system computing power is not enough. So they require this kind of problem require huge computing power, huge computations, high performance computation. So it requires supercomputing power. Like let's say this kind of scientific activities, engineering related activities. So some kind of simulations, some kind of forecasting. Single system cannot solve this problem. They need high super computing power to solve this kind of to do this kind of analysis or a forecasting or a predictions. Good idea.
Yes, sir.
Okay. High throughput computing. High throughput bin what? Throughput. What is throughput? What is bandwidth? Any idea? Hello?
In communication,
Sorry? Sorry? Hello? Okay, so throughput, we may say the amount of data can be transferred. So bandwidth, the data transmission in the data transmission process, the bandwidth is the capacity to transfer the data. So throughput also in a single point of time, how much data can be transmitted through a media. So uses the grid to schedule large number of loosely coupled or independent tasks within a goal of putting unused processor cycle to work. So if they want to do some kind of calculations or kind of computing, so they are in this throughput computing, they are using or they are utilizing unutilized processor cycles. process cycle means its capacity to compute or to analyze some data or to compute some data. So in a sense, they are collecting its unutilized processors, the power, computing power, and doing some kind of special computations. On-demand computing. On-demand computing. On-demand computing. Any idea? Hello? Hello? Okay, in this on-demand computing uses great capabilities to meet short-term requirements for resources that are not locally accessible. So here the grid capabilities. So it can be computing power or computing cycle, processing cycles, it can be bandwidth or storage, databases, or any kind of grid capabilities. It can be bandwidth or a throughput or anything. So to manage some what do you call the sudden demand, on demand, sudden demand or sudden unexpected demand, in some occasion they need this kind of computing. Let's say some seasonal computing. I mean, assume that for a Walmart or a big store, online store, or anything, e-commerce site, for a seasonal demand, like the festival seasons or any other festival seasons, their order, online orders, huge amount of millions of orders they may receive at a time, and these orders has to be processed very quickly, and they have to send the ordered item to their customers. Seasonal demand, like a Christmas or some other festival, they may receive huge amount of orders from the customers from all over the world, and they have to process this what do you call this orders, like the order details, the customer details, the payment details, and the product related details, and shipment related details, and transportations. So this huge amount of data they have to deal, and they have to handle huge amount of transactions. So on-demand computing, for this kind of on-demand or sudden demand, they may require this kind of great capabilities to complete or to accomplish these activities. They are getting this activity from grid computing because the resources required for this to accomplish this task are not available locally or not locally accessible. So they are getting the grid capabilities to accomplish or to finish it off this computing requirement. Collaborative computing. So the term itself has the meaning, it's collaborating, a concern primarily with enabling and enhancing human-to-human interactions. So applications are often structured in terms of virtual shared spaces. So applications are integrated and collaborated, and it's some other components and resource, online resources are linked or integrated to collaboratively. They are supporting or enabling to perform these computing related activities, collaborative computing. In this collaborative computing, databases can collaborate, data storage spaces can be collaborate, bandwidth can be collaborated and smoothly collaborate, and the computing power can be collaborated, and various computing capabilities, grid capabilities can collaboratively support to perform this computing. Data intensive computing model. So the focus is on synthesizing new information from data that is maintained in geographically distributed repositories, digital libraries, and databases. So data intensive computing. So basically in this case, they are going to deal with a huge amount of data. So this data can be stored or located in various locations, the distributed locations with repositories, data repositories, digital libraries, and databases. So they are going to access or retrieve the data from various locations, from various repositories, digital libraries, and databases. So that time they require data intensive computing, since they are going to deal with this huge amount of data. Logistical network. Logistical networking. The logistical networks focus on exposing storage resources inside network by optimizing the global scheduling of data transport and data storage. So basically, it's a kind of facility providing in this grid computing, the logistical networking. The logistical networking in the network. So when the data transfer, they can schedule, or they can look at what is the unutilized path and use that bandwidth or throughput. So here you see logistical network focus on exposing storage resources inside network by optimizing the global scheduling of data transfer and data storage, data transfer as well as data storage. It can contrast with a traditional networking, which does not explicitly model storage resources in the network. The traditional network is not considering this, logistical networking. High-level services for grid applications called a logistical because of the analogy it bears with a system of warehouses, depots, and distribution channels. So you know this in the data transmissions, data packet can be transmitted through various route, and sometimes when a network get thousands of requests from the users, when users send thousands of millions of requests, the network may be busy because the data is going to transfer or travel or transmit through this media. So this time the devices connected in this network can get busy because the network is transferring the data from various users or client. In this logistical networking, it can optimize the scheduling of this data transmission. Like it can redirect to unutilized bandwidth or output, and it can optimize the data transportations and the data storage, and so then it can easily find the unutilized one or the free route to get this power, the networking power, logistical networking. So we looked at 6 model, basically 6 method of grid computing, distributed supercomputing, high throughput computing, on-demand computing, data intensive computing, collaborative computing. At last, we looked at logistical networking. So these are the 6 methods of grid computing or architectures for this grid computing. With that, I'm going to conclude this grid computing part. In the next lecture, we are going to discuss middleware. client server computing, and from that client server computing, we will move into this middleware systems. Okay. So any doubt, any problem, anything do you want to clarify? Hello?
No, sir.
Okay. So you have to get ready for your first assignment. Tomorrow or day after tomorrow, probably tomorrow or day after tomorrow, I will place the assignment into your course website. You have to look at the assignment from the course website and you have to submit it online. So I will give the deadline also. Follow the instruction and submit the assignment. One more thing, I mean, very much essential when you are submitting this assignment. Last time also I look at your online submitted assignment. There are multiple duplicate. It means some of the students are copying others' work, not partly the same copy, entirely they are copying. So what I did was I put 0 marks for both person. I have already given the instructions in each assignment. Don't copy from your colleagues. If you are copying partly or entirely, both party will get 0 marks. So this time also, I observe that there are several students and their registration number also near. I mean, let's say MIT 54, MIT 55, MIT 56. Assume example, these people are copying their friends or their colleagues' work. What I did was, for those who submit the same assignment or the copy of assignment, for all the people put 0. I don't know the actual person who prepared the assignment, put the 0 marks. So don't do this same kind of copying work this time also. Each and everyone, they have to individually focus your work and you have to submit your assignment as individual. This is called individual assignment, not a group one or copied assignment. Individual assignment should be individual. Okay. Please consider this this into your mind and submit your assignment individual. Okay. By this level, I'm going to wind up today's session, and we will meet by next week. Tomorrow or day after tomorrow, you can find your assignment in the course website. Anything? Any problem?
No, sir.
Okay. See you then.